Alright, so here we have two new motors from iFlightRC.com. These are their new series, the Tachyon T2207 and T2306. And they send them in for testing, so thank you iFlightRC.com for sending the motors so I can test them and share the results. Actually, the 2207 is kind of interesting, the 1750 kV. That type of kV is becoming very popular now for 5S and 6S use. So it's going to be cool to see how this motor compares to the other low kV motors I've been testing. And the other one is a more conventional kV, 2450 for a 2306. There's a lot of motors in my database to compare this one to. It's always interesting to test out new motors from different manufacturers and see how they fare. So with these motors, they incorporated all the latest features that we've come to expect, such as the naked bottom for reduced weight, and single piece shaft, of course, that's pretty much standard these days, hollow or partially hollow, and aluminum 7075 construction all throughout, and all the bells and whistles, of course. Retaining screw for the shaft at the bottom, though that one's kind of small, so usually when they use that small screw, that means the shaft is 3 millimeters. So it's only partially hollow. It only goes all the way to the where the shaft and the bell couple right there. So partially hollow shaft. And let's see what these weigh. This come with 18 gauge wire, and the wire length is 150 millimeters. This is the 2207 motor. So that one comes in at 41.5. So that's a little bit on the heavy side, but there's probably a reason, because what I'm seeing here, this motor actually, for being a 2207, it looks rather tall. So it's pretty tall, so we'll check it out when we pull this apart. We'll measure that stator. So 41.5. so if we remove the wire so that it's only 50 millimeters left, that's 3.3 grams that you'll be getting. This is pretty heavy wire, so that adds to the weight. So 3.3 grams, let's tear that, and with 50 millimeters worth of wire, it's 38.3, so a little bit on the heavy side for a 2207. Let's measure the weight on this 2306. So 2306 is 32.6, so that's more like it for the 2306. That's pretty decent weight actually for a 2306. So those are kind of small screws, so you gotta make sure you have a good hex driver, and if they use a strong thread lock, it's better to heat up those with a soldering iron, because these are easy to round, the heads on these screws, and when you start turning them, even if you get a good hex driver, because of the thread lock, you'll end up rounding the head, so better to apply some heat. So I'll show you how to do that. I left the soldering iron on the retaining screw for about, seems about 10 minutes. The motor is still, as you can see, is still comfortable to hold, and I don't feel that much heat on the shaft either, so should be safe. I don't think it's gonna damage the windings or anything. Of course, every motor is different, so it's always a good idea to check the temperature, make sure it's not overheating, because the transfer of heat might be different from motor to motor. But in any case, you have to approach carefully and keep checking temperature, make sure it's still comfortable to touch. This thread lock they're using is pretty strong, so I had a hard time just trying to turn it without heating it up. So I gave it the old trick of heating up the retaining screw. Then you have to make sure you use a good hex driver and push in and slowly twist, and then you'll feel it break loose. So that really works quite well. So definitely you have to heat this up. I tried doing one without heating it up, and I kind of messed up the head. So that one's gonna have to be extracted different when it needs to. And this is quite a long screw, as you can see. Pretty long. I don't know why they're using such a long screw. Unfortunately, they did use these small head screws. It's a 3 millimeter shaft from what I can see here. So that's, you know, that's why they have to use these smallish screws. I wish they had a M2 screws with larger heads, or at least a taller head, so you can really have more area to make contact with the hex driver. So once removed, should be easy to pull the. So it's pretty easy to pull the stator off the bell, and there we go. Alright, so here's the motor taken apart, and there's the stator. So pretty good job on the windings there. Looks to be multi-strand wire, and as well as I could count, that's about 5 strands per bundle of wire. So interesting way of winding. Usually I'll see bundles of 3, maybe 4, but I counted 5, so but it's kind of hard to count, but I think it is 5. And the bearings, they're 3 by 8 by, seems to be by 4 millimeters in height. So usually those bearings are pretty good. If you recall, if you remember the Emax motors, the legendary Emax RS, they would have a 3 millimeter shaft, and these size bearings 3 by 8 by 4. So much better. These 8 millimeter bearings work much better when you have a 3 millimeter shaft than when you have a 4 millimeter shaft, because what ends up happening with the 4 millimeter shaft, you end up with the smaller balls, and those don't do too well because they're so small. In this case, because the shaft is only 3 millimeters, so you have more space here inside the race of the bearings. They can use larger bearings, so those last better than the 4 by 8 by 3. Alright, so let's measure the height on that stator. This motor looks a little bit too tall, and it's a little bit too heavy to be a 2207. So let's see, that's 8 millimeters, so it's definitely not a 2207. So it's a 2208. So I don't know if they mislabeled the motor or what, but it's actually a 8 millimeter stator. Not a bad thing, I think. You get an extra millimeter of stator. Of course, it's gonna make it a little bit heavier, so if you were counting grams, that's not the way to go. But if you want a little bit more power and more efficiency, then the extra millimeter will definitely help. Anyway, as you can see, 8 millimeter on the stator. That's why this 2207 came in a little bit heavier than most other 2207s, because the 2306 is pretty much in line with all the other 2306s, so it wasn't like a surprisingly heavier weight. It was very comparable to all the other 2306s that I've tested and reviewed. Magnets are arc magnets. There's a lip right there on the ring, so that helps retain the magnets. 3 millimeter shaft right there, so it's not hollow, but it's got a very long thread, so it's partially hollow because they use this really long, as I showed you before, that's a really long screw with a very they're using that white thread lock. I hate that thread lock, that gets pretty hard, but I guess the one good thing is that if you heat it up, it does loosen up. And here's the stator for the 2306. Somewhat different, as you can see on this one, they're using single strand wire in the windings, so different approach on this stator. And let's have a measurement there on the stator height. So that one's 6 millimeters, so no surprises on this one. And again, they're using the same 3 by 8 by 4 bearing, so 3 millimeter shaft on the bell, and pretty much the same componentry, same construction, arc magnets, a balanced bell, and a lip right there to help retain the magnets. So actual construction on the motor itself is actually looks pretty good. It looks very well made. Of course, the ultimate test is when you crash the motors and you end up banging them and see how they survive abuse. So that's the ultimate test. Alright, so let's put it together and check out the air gap. Alright, so there's the air gap, somewhat tight, as you can see there. It's not extremely tight, but looks pretty good. And that's the same on both motors. That was the 2306. On the 2207, 2208, also pretty tight. So that should make for pretty powerful motors. So we'll put this on the truss stand and see how they perform, and let's see what kind of numbers we get. Alright, so let's have a look at the truss test results for this new motor from iFlightRC.com, the Tachyon T2306-2450KV. KV came in higher at 2560 kV as measured, and weight of the motor was 32.6 grams, so very good weight for that size motor. So based on that KV, I tested on 3S, 4S, and 5S, the usual props, starting with the GenFan 5045BN 2-blade prop. So pretty good start at 1500 grams, 41.5 amps, so pretty manageable there. So keep in mind these are maximum burst figures, so those are max amps and they're only present for a very short time. And the equivalent in flight is usually 35 to 40% lower, so when you do the calculation, these are going to be quite manageable. So above 1500 for the less aggressive props, and as we move on to the more aggressive props like the HQ 5045x3 and the dial C5046, we're getting close to 1632 here for the dial, and the 5.5 inch prop 1732, so that's good. And then on to the 6-inch props, we're seeing close to 1900 here for the 6040, and on 3S 6040 1300 grams, could be usable for those people that like to run 3S. On 5S 5043x3, this motor really wakes up, and 1900 grams of thrust at 54.4 amps, so that's equivalent to about 33 amps in flight, the equivalent 40% lower from the burst numbers here. So overall, very good results out of this motor. Okay, hope you find the data useful, and thank you for watching, and until the next video.
UK bit.